Welcome everyone. This is the WasmEdge community meeting. We've got quite a few people online. That's good to see. And it's about 1 minute past the hour, so I guess we'll push on and kick this off. So again, welcome to everyone. And we've got an agenda tonight. We have first up Heide presenting WasmEdge 0.9.0 preview, and then we have managing WebAssembly apps with Kubernetes, Containerd and CRIO by Michael. I'm going to be presenting WasmEdge on SEL4, and we'll have a bit of Q&A at the end. And these are, fairly intimate and a little bit casual. So if you've got any questions, please feel free to jump in, ask questions. And we're here to help. We're here to support the community and see what you guys are doing, what you've done, if you need any help, and so on. So we'll kick things off. First of all, Heide's going to take it away.
Okay, let's start. And today I'm going to do the WasmEdge 0.9.0 preview. So in this slide, I will go through from 4 parts. The first one is the breaking changes. And in this version, we do lots of the breaking changes. So if you are using our C API or Go API, you may interested in this part. And also we have some new features and lots of issues fixed and some other parts. So the first thing of the breaking changes is the proposal part. Just a few days ago, the SIMD proposal is now in the standard spec. So we already set the SIMD proposal enabled by default. And if you use the CAPI, the configuration in the configured context about the SIMD is enabled by default. Also, if you want to disable it, we have option that is disable SIMD. You can disable it in WasmEdge and WasmEdge C. Okay, so the first part is about the SIMD proposal. And the second part is about our performance. Actually, we have an issue on our WasmEdge GitHub repository. The number is 473. If you are interested, you can go there to see the profile information and how we figure out the relative performance issue and how we fix it. So before this version, the statistic module is enabled by default. So this is the first part. And this will, it will consume some performance because we need to calculate the gas metering, we need to calculate the instruction count, and so on and so forth. So it will cause some of the performance. So in this version, we has disabled it. And if you want to re-enable it, you can use the following options or use the universal option to enable their own. Okay. And so this is about the performance part. Yeah, so we do some changes in the statistic modules. Then we want to talk about a new format of our our compiler output, which is talk about the which is called as universal Wasm binary. And before this version, our WasmEdge C will compile your Wasm file into a shared library. So you have no chance to maintain your original Wasm after we generate this new file. But in this version, we enabled a new format called universal Wasm binary, which is it will output your original Wasm file with a custom section which contains our native code. So it will, it will looks like the fat binary in the new Mac OS. You can, the fat objects contain the Intel model and the M1 model binary. So this is the same concept. In this version, you will get a new file code. It still is a Wasm file, but with a customization contains our native binary. So you can use this file in other runtime just like its origin behavior. But in our WasmEdge runtime, if we find your file contains a custom section with our native binary, we will use the Aot runtime to execute it. Yeah, this is just output format changes. Okay, then there's lots of changes in the CAPI headers. So if you are interested, you may need to check the change log by yourself because this is very complicated. So I just mentioned some of them. Yeah. So the first one is that the folder is changed. Before the 0.90, we only have one file called wasmedge.h. But after this version, we will create a folder in your included folder, which is the wasmedge/wasmedge.h and lots of the emulation files. So this is the first big change. And also we rename the components. For example, the interpreter component is now renamed to the executor. So you will find lots of the files and the class name and the function name are changed. Okay. Also, the host function part is now renamed. The host function is now called the function instance, and just lots of the remaining. And also we have a new type context, including table type, memory type, global type. So now you can use the new type context to, to create your instance or to, interact with your with this instance. Yeah. And lots of changes about the instance creation. Also, we have changed some object life cycle. So some of the objects should not be deleted before we release it. So you have to check the details in the change logs because there are lots of the life cycle changes in our CAPI. Yeah. Also, the remaining part interpreter now called the executor, and because we changed the statistic, so you can find lots of the the statistic function is renamed and it's changed the behavior. Yeah. And also we changed one parameter in the WASI part. Normally we only have arguments, environments, and preopens in WASI. However, before this version, we have a special parameter called the directories, which is unnecessary because it's just the same as the preopens. We just we forgot the reason, but we just add a redundant part in the API. So we also remove it in this version. Yeah. Okay. So there's lots of the breaking changes, and most of them are happen in the CAPI. So you may need to check our document for the details. Yeah. Now let's go to the new features. So the first thing is the proposal options. Because the following options, actually, they are related the corresponding old proposal, which is already in the Wasm standard. However, some of the users want to disable them, so we provide an option for them to disable the old proposals if they want. And we have some new features in CAPI. For example, and we create lots of the functions about our AST module. So you can now check the import information and export information, because we are integrated with the proxy Wasm proposal, and different implementation will need our runtime to provide an interface to query the import section and export section before we initialize, instantiate the module, before we instantiate it. So we will need to create a new API in the AST phase. Yeah. So that's about the new CAPI feature. Also, we have a new functions which can get the exit code when you execute the WASI main function. Yeah. Okay. Then lots of the this is not WASI, this is the Aot Compiler. Yeah. Just I mentioned before, we changed some of the the universal Wasm format, so the API related option is also changed. Okay, so that's our new features. And we also fixed some issues. That is, for example, the first part is the loader issue. Before this fix, you will also always get you cannot load this file. This file is not Wasm or something like that. But actually, it's loading the Aot native binary, and you will now get the correct error output of this kind of error. So that's the first thing. We just fix lots of the error message in the loader part. And the next two are also related to the Aot mode, because in the loader section. Yeah. For example, this one is that before this version, we are not allowed the literal address use in our Aot mode, but actually we should allow it. Okay. And the other one is that if we want to load the Aot pre-built native binary, and we forgot to initialize the interested table before this version, so it will be it will create a random fail, the segmentation fault, when we want to initialize it with our native binary directory. Yeah. Also, thanks to the contributions from the community, actually we update the following two parts about our WASI socket. So the first one is that before this version, some of the socket module in Mac OS is not working because we forgot to add some header or lack of some definitions in Mac OS. And also we have a redundant parameter called port in the socket accept function. We also remove it in this release. Okay, so our fix the issues. And the final part is we now have the Go API documentations in our main repository. So if you are using WasmEdge Go, now you can have you can have a documentation to look up. Before it, you have to dig into our source code and find how it works. But now we have a documentation for it. And the second part is that we have the install and uninstall script. So you can use our install script to install our pre-built binary and our libraries and Linux, including the including the AMD 16.4 model and also the ARM architecture. Also on the Mac OS, we have pre-built binary and library for the Intel model and the M1 model. Yeah, so that's all of my WasmEdge 0.90 preview. Thanks.
Thank you. Excellent. Thanks so much. Yeah, that all made a lot of sense. I have a couple of questions, but I'll leave them for the end. Thank you so much, Heide. Excellent. So next up, we've got Michael, and he's going to look at this. The CRIO is the implementation of the Kubernetes container runtime interface, and this enables the Open Container Initiative compatibility. So Michael's going to have a walk through that for us next. If you're ready to go, hey, take it away.
Hi, thanks, Tim, and thanks, Heide. And okay, let me share my screen as well. I also want to give you a little preview of another project that we're going to release with 0.9.0. You know, that's a new documentation site. That's, you know, our documentation in the past has been mostly scattered around in the GitHub repository and in our article site, and, you know, things like that, and in Medium. So we have put all those things together into a book format. It's called MD book. You know, that's it's what the Rust team has been using to organize their documentation as well, used by a couple of different projects. And so, you know, so we have all the we'll have all the book sources in MD format in the WasmEdge repository, and have a build of this book. Currently, it's only in English, but I think you know, we are looking for, you know, many more new languages in the future. You know, on the WasmEdge.org website. So it's going to be wasmedge.org/book/English/Chinese/whatever, right? You know, so the book has many sections. You know, you have getting started guide that's covered install, uninstall using Docker command line, and it has what is WasmEdge. You know, in this section we have all the, you know, the content that's currently on our website. You know, like use cases, feature highlights, and, you know, things like that. And then would be the big sections are the 3, 4, 5, and the 3 is developing a WasmEdge app. It's goes into different languages, you know, like how to do it in Rust, different features in Rust APIs, how to do it in JavaScript, you know, different features in JavaScript. You know, if I want to use Node.js module inside WasmEdge, right? You know, so you know, first, why I want to use run JavaScript applications in WasmEdge, and then, you know, networking using mixing Rust with JavaScript, and, you know, things like that, different languages. And so that's how to develop a WasmEdge application. And then the next section is how to embed WasmEdge functions into another host application. So that includes our CSDK, Go SDK, you know, how to, you know, call functions as memory pointers and all that. You know, so those information currently is all scattered around in our, you know, articles website, and also, you know, our documentation site. And we'll pull together all the different examples. So now I want to talk about the topic I want to cover in this call is WasmEdge in Kubernetes. You know, so is a whole section in the book that essentially, you know, is a promise WebAssembly has made since 2019, is to say run WebAssembly as truly as a container, you know, instead of you know, embedded runtime that you have some other application and then put the WebAssembly inside of the container, or use other application to bootstrap WebAssembly, right? So what we want to do is to run WebAssembly truly as a container image and run it side by side with, say, Linux container images, and or in a Kubernetes cluster, right? So how do we do that? You know, that's I think this graph shows the architecture very well. This is essentially the architecture of Kubernetes. You know, at the bottom, you know, there's images, right? You know, so it used to be just the Linux container images that you put on a repository, say Docker Hub. So you have container images, And now we added another format called WebAssembly images, and we use the OCI format to package WebAssembly applications, so that in the image there's just a single WebAssembly application. There's no operating system components. And so if you run those WebAssembly images, you can publish those WebAssembly images to Docker Hub. But if you actually run those, you would with the Docker command line or with containerd, you would actually get an error. It would say the image format is wrong, because it was expecting operating system, and you don't have it. The image only have a WebAssembly file, so it wouldn't know how to run it. So in order to run it, we have to make the runtime, the image runtime, available, aware of the aware of the new image format, right? So in that sense, we need to change the low-level container runtimes, which what they call the OCI runtimes. There's a couple of OCI runtimes available in the ecosystem, and that we worked with one of the most popular is called CRIO, and the CRIO is there's the names can be confusing. Run C is run container, but written in Go. CRIO is the C version of run C, right? It's so at the binary level, they're interchangeable. And there's a bunch of others. There's one written with Rust. There's one that's written with more security in mind. It's called gvisor. Google did it. And then there's Kernel runtime and things like that. So we initially we because all of them are interchangeable at the so CRIO and run C, for instance, they can perfectly replace each other. You can just rename the binary and it's going to work. So we work with the CRIO developers to incorporate WebAssembly and WasmEdge capabilities, in particular, into their release, right? So at this moment, you can build a version of CRIO that can recognize both Linux images and Wasm images. So meaning that using this version of CRIO, if it sees a Linux image, it knows how to run it as usual. And if it sees a WebAssembly image, it knows to extract the WebAssembly file from that image, and then you use WasmEdge to run that file. So we made, with this small change to CRIO, we would, because all the other high-level stuff, because in the whole ecosystem, you have OCI runtimes at the bottom. And then above the OCI runtimes, those OCI runtimes are managed by the CRI runtimes. The CRI runtimes are things like CRIO, containerd, podman, things like that. They manage CRIO and run C, right? So with CRIO aware of both image formats, the upper level container runtimes become automatically aware of those image formats as well. And then those higher level container images are further managed by orchestration frameworks, which are Kubernetes itself, or variations of Kubernetes framework like KubeEdge, SuperEdge, OpenEdge. That's all those variations. So they become automatically aware of WebAssembly application images as well. So so that goes up the whole stack, right? So so this is a brief view of the architecture. So essentially, we created a new, I wouldn't say a new, we created a way for people to build, WebAssembly applications into OCI images and publish on Docker Hub, and then modified CRIO so that it can run both Linux images and WebAssembly images. And then the rest of the ecosystem can just use the modified version of CRIO, and everything would fall into place, right? So then we have quite a few examples to show how to do this, right? So the quick start is just I would say a scripted walkthrough of the whole thing, right? So it's based on CRIO and CRIO. And by the way, all of this is available in GitHub and also available as GitHub Actions. So you'll be able to go into, you'll be able to follow those links and go to our GitHub website and see exactly how those scripts are written. Some of those are written by Tim. So that's so, and you can see how those scripts are run on real machines through GitHub Actions and see their output and all that stuff. So this, for the quick start, there's just a couple of commands. You know, you can run it on your own machine, and it's gonna work. It's gonna set up the Kubernetes. It's gonna set up CRIO, CRIO, Kubernetes, and then run very simple applications for you. You know, so it's you know, it's a nice way to get started on your machine and see everything works, and it's also works on GitHub Actions, of course. And then we dive into deeper into the you know, exactly how we do it, right? You know, you remember the figure I have just shown. At the bottom, those are Linux images and the WebAssembly images. So those demo applications are how we build those WebAssembly images. So basically, you have a application, you know, that is written in Rust. So you install Rust first, and you register for Docker Hub, and then you have two simple applications. One is a simple Wasm application, meaning, you know, it does some computation, it generates random numbers, and then generates some number sequences and print it to the console, right? So you have an application like this. You know, that's it's all. You know, you have a GitHub repository here, and you can download the Wasm file directly, and then here it goes through the instruction on how to build it. And then you have another example is HTTP server example, which use our the WasmEdge HTTP socket API. What it does is that it builds a HTTP server, and then it responds to HTTP requests, right? You know, so here is also, you know, in this article, it also goes through the process of, you know, checking out the code, build the code, and then, you know, package it into OCI image for Docker Hub, right? Create the Docker file, and you can see, you know, the Docker file has an operating system in it. It's just from scratch. It's add this Wasm file, and then, you know, it's so for the CRUN object, you know, for the CRUN runtime, when it sees a Docker image like that, it knows to extract this Wasm file out of it, and then you use you know, the WasmEdge runtime to run it instead of using Linux to run it, right? You know, so it has all the instructions on how to do it. You know, as everything with Kubernetes is fairly long, it's fairly complicated. That's why we have the quick start. But those are the two examples. And with those two examples, you can go. Let me move this a little. Okay. Yeah, with those two examples. We just talk about those two examples, and then we can go forward to upper level, right? You know, so now we have the WebAssembly images. Now we go upper level. We can talk about OCI runtimes, and now we only have CRUN implemented, but we have runc and Yuki planned in our wish list, right? You know, so if you are interested in contributing those, you know, we would love to see that, you know, because those three are essentially equivalent. So, you know, it's just written in different languages. And so let's see how to configure CRUN to do this. And it's very easy because CRUN developers has already incorporated WebAssembly. So what you do is that, you know, just go directly from the official source code of CRUN, and then build it with a WasmEdge flag, and that's it. You know, you would have a binary distribution of CRUN that is WasmEdge capable, and you still have to do that because it's still an experimental feature. You know, it's a feature that we just added. You know, it's going to stay as experimental feature for the time being. So, you know, so you have CRUN, and you know, the documentation talk about runc and EOK, but it's coming soon, right? You know, once you have CRUN, you can configure your CRI runtimes, namely CRIO and containerd. You know, so the idea here is that to explicitly configure CRIO and containerd to use CRUN, you know, because they come with their own. I think they come with runc, their own version of runc, but we need our custom build of CRUN to do that. You don't really need to configure that. You know, if you want to take a shortcut, you just rename your CRUN binary into runc and override your runc. That would work. But the proper way to do it really is to install CRON and so on, and then configure CRIO and containerd to use CRON as their underlying runtime. And so, so the process, we have documentation to, those pages to go through all that. There's so there's a couple of sections. You can install CRIO and configure CRIO and CRON. If you do this, basically there's a configuration file in CRIO that says default runtime is CRON, and that's it, right? And then you can run those the two applications that we talk about. The two applications are already uploaded onto Docker Hub, so you will be able to from here you will be able to use CRIO to pull that and to run that. Because now that's you can use the command line to pull, and you can and then you have two configuration files that basically tells it how to set up the container, and then you can run it, right? So then you can see the output of this application, here. And then the second application, the same thing. You can pull it, and then you have configuration files. You download two configuration files, and then you can run it. Once you run it, you can and then you can use curl, because once you run it and you inspect the status, it will tell you, where it's running, and then it give you IP address, and then you use curl to make a HTTP request to the IP address CRON assigned CRIO assigned to the WebAssembly application, and then now you can see the outcome, which is an echo, right? So now we have the whole thing that's running on, that's now we have CRIO running CRON, running the a WebAssembly image that we have just built, the two WebAssembly images that we have just built, right? So the next step really is to make CRIO running in Kubernetes, I think. Well, but before that, let's look into containerd as well. So we just talk about, there's two. There's also multiple CRI runtimes that are competing against each other, right? CRIO is one of them, containerd is another, perhaps more popular. So we can also configure containerd to use CRON instead of its default run C. So that's this process goes through that. That's it's actually even simpler than CRON, than CRIO. So you install containerd, and then you run those applications by passing this passing this, to say the run C library is now CRON. It would automatically work. That's you would be able to tell it where to pull, and that's where the image come from. Where this is where the image come from, and the other meta parameters, and how to, and the command line you have to pass to the image, and then it would be able to run it, and it would be the same thing for the HTTP server. That you can and in this case, we use local local network for the host. So you would make the HTTP request to your local host, and that'll be it, right? So now we can run at the CRI runtime level. Both CRIO and containerd can now use our modified CRON to run our WebAssembly images. So the next step, really, is the final step, is to run in Kubernetes. And see, so in Kubernetes, there's also different ways to run it. I think the way that we have really expanded out is to use Kubernetes plus CRIO. Meaning that we use Kubernetes as orchestration, and then CRIO as a CRI runtime, CRON as the OCI runtime, and the WebAssembly images and Linux images, right? So here it shows how to do that, the whole process. By the way, all those have quick start sections. If you don't want, because this is a length, every article is a lengthy instruction of things to do, and we have made all those into scripts so that you can see it running on GitHub Actions, and then you can download those scripts and run on your own computer as well. So here that we have the process of first installing and start Kubernetes, which is a fairly involved process, and then to say I want to run those in Kubernetes. I mean, that's that assumes that Kubernetes has already configured I think here that Kubernetes is already configured to work with CRIO, and then at Kubernetes level, you don't really need to know anything about WebAssembly or anything like that. From Kubernetes point of view, it's just another image on Docker Hub, right? So you would be able to just run it and you see the result. And then, so that's one of the interesting things is that the higher up to the stack you go, it becomes easier, because all you need to do is to do a standard installation, because all the low-level stuff is being taken care of when you configure CRUN and the CRIO and the containerd, right? So Kubernetes or CRIO, Kubernetes or containerd, we actually have documentation. We just don't, we don't have, we haven't added to the book yet. And Kubernetes, WasmEdge, which is another one, I just have this. I just had the documentation ready last night and have not had the chance to move it to the book yet. So all those things can happen, gradually in the next couple of days. And so I really look forward to the new release of WasmEdge, and then we can make a public announcement about this book website, and also for all the content that that we have on it. That's so I think WasmEdge Kubernetes is a great topic for the book, because it's such a complicated topic. If you write an article about it, it's going to be very, very long, and it's because it takes at least 20 minutes for people to follow through that, right? That's it's essentially a complete workshop material. And by having this book, that we would be able to divide it into sections and be able to build from ground up from the demo applications to the OCI runtimes, to CRI runtimes, and then to Kubernetes themselves. So that's yeah. And there's a bunch of other sections in the book. Since now I have your attention, we have application frameworks and platforms, meaning that's how WasmEdge is being integrated through SDK, also Kubernetes, into higher level application frameworks. So for instance, there's, if you click into here, you'll see, I don't know why my computer is so slow. Okay, the Dapper framework and the Wasm framework. And then you have application frameworks that's, say, there's Reactor and YOMO, that's, those are, Go-based application frameworks that you can also use by integrating through our Go SDK. You'll be able to, bootstrap, WasmEdge application directly in there. And then there's a section how to contribute to WasmEdge. That's goes through the process of building WasmEdge from source, and then also how to use our plugin APIs to add new host functions. There's different ways to add host functions into WasmEdge, right? So for users, they can use our SDKs. Essentially, they're building customized version of WasmEdge. And for platform developers, if you want something to be added and distributed with WasmEdge, you can use our plugin API. That's that is C++ based API. That's, I think, quite a few people have used. We have like 4 intern projects with CNCF that are using that API. And then the last section, we have operating systems. Where does WasmEdge run? And as you can see, we have standard version of Linux, Windows, Linux, Mac. And we have real-time operating systems. We talked about I think Tim going to talk about Cell 4. And then we have, we are working on, making WasmEdge available on Open Harmony as well. And, we have some issues on our GitHub that's currently being resolved. And so if you are interested in that, we are very interested in, having discussion or having contributions from that area as well. So yeah, that's it. So back to you, Tim.
Yeah, excellent. Really good. That book is fantastic. Really awesome. Thanks so much for that. I think it's really valuable for the community to see that the different levels of container runtimes, and that really makes it clear, because it is quite complicated. Each one you dive down quite a deep rabbit hole. So it's really nice to just see that all laid out, and yeah, that's really nicely done. Excellent. Thanks so much. And yeah, as you mentioned, so I'll be doing this quick presentation on the WasmEdge and SL4. So I will just share my screen. Just move this aside. Well, firstly, just quickly touch on what this microkernel is all about. So this website here, you can go to sel4.systems, and this is a website which will give you quite a lot of information. Essentially, we'll just break it down and say that this is a microkernel. I'll just move that out of the way. So being a microkernel means that it's reduced to a minimal core that's free from policy and therefore can form a dependable base for building arbitrary systems serving many different usage scenarios. And the microkernel versus kernel, so the kernel obviously being a piece of software that runs at the heart of a software system and controls access to resources, controls communications between components of the higher level system. Now, we ask the question, what is the intended applications of SEL4? And the answer is all of them. So SEL4 is a general purpose microkernel. So the main targets are embedded systems with security or reliability requirements, but that's not exclusive. Using a microkernel like SEL4 makes sense on platforms that provide virtual memory protection and for application areas that need isolation between different parts of the software. And so immediate application areas are financial, medical, automotive, avionics, and defense sectors. Now, there's some similarities between the security constraints, if you will, in relation to WasmEdge and SEL4. We'll just quickly demonstrate. We have a GitHub repository and video and a few different things. We'll just demonstrate how to run WasmEdge on this SEL4 real-time operating system. So the source code, you can find that. You go to Second State GitHub, and there's a WasmEdge -SEL4 repository there, and you'll see there some great documentation from the team. There's a great README file. It essentially steps you through. We'll take a look at that in a second. And this diagram here, which outlines this, the sections that are containerized runtime, the applications in the runtime, and how it all gets pieced together. So if you go check that out, this is some excerpts from that. So the first step is essentially to, you can use this all-in-one build script, which is really convenient. There is another method in the README file that you can go through the steps, one by one and do that manually. But this script is great. If you go ahead and build that, this builds an SEL4 simulator, and WasmEdge is installed during this build process, and any dependencies and patches and things are all applied. So this will get you up and running. The next step is to actually just move into the SEL4 WasmEdge /build directory and just run the simulate command. And this is essentially running the simulator at this point. Now, we log into the guest operating system. So once you've done that, you're then able to execute the Wasm examples. Now, at the moment, there's two in there that are set. The first one is one of these ones where we'll just, generate arbitrary numbers and things like that. So you can go ahead and run just with that command there, the WasmEdge _emit, and that will execute the Wasm file and give you back a result similar to this. And the next one is just like a hello world. It does a couple of things. The first thing is it responds back with hello SEL4, and the next thing in that particular Wasm executable is that it performs a little bit of computation. So the output that you'll get is fixed in this case, and as you can see there, it's like hello, and then 1 + 2 - 3 × 4 = -9. So that'll execute for you. There is a video of the entire process from start to finish, and it's available at that URL. We can provide a link in the descriptions when this goes out on YouTube. And the place that it will be is somewhere where you can find the video anyway. If you go to YouTube and go to the Second State channel, you'll see the this video there on that channel, and amongst other things. And also this is where the these WasmEdge community meetings also are posted there, so you can go ahead and find that. So essentially summing up the use of these two, the SL4 and WasmEdge, they both have these deliberate security design principles, and this is a really key component of it. WebAssembly has obviously WASI, and this is implementing capability-based security. And this is where the host must explicitly grant a capability to a guest module in order for the guest module to perform an action. So by default, it's highly secure. And similarly with SL4, the components can be properly isolated from each other. And in this case, communication is only possible through explicitly provided channels. And what this does is it provides the highest assurance of isolation between applications which run on the same system. Now, this is both with WebAssembly and with SL4. This is leaning towards running untrusted code on shared hardware, which is an area of huge potential, with everything from just wanting to minimize the amount of hardware that's in a system, and also looking at things like, you know, production levels of microprocessors, microchips, and things like that, potential supply chain issues with obtaining enough chips to actually implement what you're trying to do. And so areas we talked about at the start, this is useful and has immediate applications in finance, medical, automotive, avionics, and defense sectors, and more. So the automotive sector is a really great example. You have multiple control units in a vehicle for engine, air conditioning, you know, infotainment, safety, all sorts of things like that. And if you can get to the point where you can actually start running different modules, like different programs of untrusted code or unrelated code even, on the same hardware, on shared hardware, this is a huge step forward in you know, upping production and maintaining and sustaining manufacturing and things like that. So really great potential. And go ahead and check out a couple of things. So obviously secondstate.io, you'll find all of the information and links there. The other place you can go is, of course, the wasmedge.org. And if you go to the GitHub that I mentioned before, you'll see the demonstration laid out there, and feel free to give it a go yourself. And as per the video, we just run through. It's quite simple. You just execute all the commands. And if you've got any questions, there is the opportunity to put GitHub issues into that particular repository. And also you can get in touch with us, you know, during any of these mediums. So that is time for some Q&A. It's great to see some people in the chat and some people online. So, okay, some questions and answers. Has anybody got anything that they'd like to learn more about? Feel free to just jump in and unmute yourself and ask away. So I've got a question for Heide, just quickly. With the presentation you gave, I'm curious about the gas measuring. In the past, when I've actually turned that on and off, I noticed the performance was excellent. Anyway, I think it was, it mentioned there's like a little performance hit when you're implementing the statistics. I think that's a really amazing feature. Of course, you know, having this deterministic execution and being able to actually measure the computation, and there's a million uses for that. And I'm just, if you have a quick second or want to just talk about how that performance is altered by enabling the statistics, because like I say, I've noticed when I've turned it on and off, it's still unbelievably fast, which is good. What are your thoughts about that?
Okay. Actually, we talk about you know, the gas metering, which is that we will count in every instruction, because before we execute the instruction, we have to minus the gas will be used in by this instruction. So you can you can imagine that there is a big for loop, and each time you will add the cost of the corresponding instruction. So if we disable the statistic, we will just reduce the at the cost instruction at the cost this part. So if you take deep look in the issue, you can find that after we disable the gas measuring, we reduce lots of the addition instruction in native code when in the interpreter part. Yeah, so that's the first things it will affect the performance. And the second part is we have to maintain a gas table, because each instruction has different gas cost. So it's not just execute at the gas cost command. It also have to look up the gas cost from a hash map. So if we can disable the statistic, we can reduce all of the cost, including the hash map lookup and also the gas calculation. Yeah, so they will reduce lots of things in the interpreter mode, and also in the AOT parts has the same behavior. Yeah.
Fantastic. Thank you. Excellent. Great explanation. Awesome. We have a question here in the chat from Brad Jones to everyone. The 0.9 release, is there an estimated time for that to be released, i.e. before the holiday?
Yes, I believe we will do the release this week.
Oh, okay.
Yeah.
Fantastic. Right. I have one other question, just quickly. You mentioned the zero address in the ahead of time compiler optimization mode. Could you explain what the zero address is about to the community? Just mention that slightly.
Okay. Actually, the part is that, and we compile the binary, native binary, but we have some limitation that you cannot put the the whole code section in the address 0. Just the very very detailed implementation design. Yeah. So in some cases, the generate outputs will need to put the code section just from the address 0. But before we encounter this this test case, we didn't notice that. So we just just forbidden it, but it is a not necessary check. Yeah, so we just remove it. Yeah.
Oh, right. Okay, got you. Perfect. Thanks. Awesome. Yeah, excellent. All right, great. So we're almost at the 1 hour mark. I'm very happy to take questions though. If anybody's got any questions or comments or ideas or projects they're working on, or if you wanted to help out in a certain section, just grab some more info with us while you've got us online. Feel free to jump in. Don't be shy. I see some familiar people in here. All right. Well, if nobody's got anything further, that's really great. Thanks to everyone. That's some really great information. And we'll have this recorded, and post-production we'll publish this on YouTube, and you can watch it back, and we'll obviously put in any relevant links and things like that as much as we can. Thank you guys so much for being with us, and thanks for watching. and we'll see you again next time.
Thank you.